To get started with the actual QTO, I will copy over one of my final files from deliverable 6. That's where we worked on the actual proposed design additions, and we want to make sure we include all of those scorecard additions and all of the BMPs. So I'll go to make that copy and open this up. Your file is likely in a better state than mine is. I didn't go through all of deliverable 6 when I was recording the videos, so for example, I still have my watersheds on this one. So I'll be right back. Just going to speed it up a bunch and clean this up a little bit. All right, so I cleaned up my site a little bit. Yours hopefully has a lot more stuff on it than mine does right now, but I'm just going to demonstrate how to use the tools a little bit, and then you guys can do it for at least, again, your 5 items, if not more. So under the Analyze tab, we can go over to the right, and we'll see our 2 tools that we need, QTO Manager and Takeoff. If you open up the QTO Manager, opening up the QTO Manager shows this UI, and on the top left is where we can open those files that we made. So we can open up the pay item files as CSV files, which is how we save them as, and just navigate over to where you have them. I just want to point out really quickly that there are built-in files for this. They're kind of hidden, but they do exist. So I think it's Autodesk. That doesn't look right. It's program data, I think, then Autodesk, Civil 3D 26, Anu, and then data, and then pay item data, and then getting started. So it's really far in there, right? But here you can see a CSV file that can act as some of the pay items. Now they just include a lot more than what we need. They also include some stuff we don't need. So I thought it was better just to make your own. It's a lot easier to navigate, but those do exist. So there's the pay items themselves and also a category file. The category file pretty much shows your pay items as divisions, the same way that the website does. It does that here as well. So really, it's not necessary. The one that we made, though, is the one that we're going to use here. And you don't need a categorization file. Just leave that blank. Hit OK. Okay. It looks like it wasn't opening because I had the file open in Excel. So just clear that up here. And now you can see the ones that I made here. You can also see the units and an opportunity to put in a formula, which we will be doing in a couple of minutes here. So now that we have this, we can assign values, or items rather, to these different codes, and it will automatically quantify what we want it to. So, for example, let's start with the light poles. Now, you maybe added some your own. I'm just using the ones that already existed as a demonstration. So here, you can right-click on a pay item and click Assign to Pay Item. Now it's asking you to select an object, and you can go through and select an object. You'll see it says Pay Item Assigned. So I clicked my objects. Now there's only 3 here, so it's not like there's that many. Definitely could have just counted them by hand. But it's also cool that it can do it itself. If you hover over it, any item, you can now see there at the very bottom of the properties, there's a pay item label with the pay item assigned to the material or the item in your model. So this is a way of checking to see if it actually got assigned correctly. We can do the same thing for the tables here. I'll right click this and click assign pay item, and then I will select my tables. And it looks like those got assigned, so I'll hit escape and just hover over them to make sure they all have pay item tags on them. Great. So now we can do an area object. So I have fertilizer here. Imagine fertilizer is basically being used on the wet swale. So I need to calculate how much fertilizer we need. Instead of doing assign pay item, I'll do assign pay item to an area. So same right click, select. And now it's asking you to select a point or select object. I'm going to switch to select object, and I'm going to click the boundary. When I select the boundary, you can see it got really dark. It got really dark because it added its own hatching to it. You can see this hatching. There's two layers of hatching. One is the one that I made previously. One is the one that it's making to show that it is calculating that area. So I can change this to some type of pattern here. Maybe grass. And then just increase the scale of it here. That's way too big. Like, go smaller. Yeah, sure. There we go. So that's how you can tell if you got an area. It should hatch it in whatever area you're assigning it to. Now, the last one that I'm going to show you is how to do volume. So volumes are kind of interesting here because we aren't actually going to be calculating a volume directly from our model. So I will go over to concrete for our concrete pad. And here I will do the same thing I did and assign the pay item to an area. Again, I can do a point or an object. I think a point would do anything inside of it like that. And that's all of the concrete that I'm using. I'm just going to change this hatching pattern really quickly to concrete. And that's great. We have the area of it, but we don't have the volume. So that's where this formula bar here comes into play. If I click on this, it's going to ask, well, it's going to tell you that formulas have to be written to an external file. That's totally okay. It's just going to create a formula file for you. So click OK and select where you want that to live. And I'll just save that there. And this window comes up and allows you to create formulas. So I'm on concrete right now, and I know that for concrete, we want the volume. So here you can add parameters, functions, and also do a bunch of like logical operators for math. So I want to take the item area here. You can also take item length. That's a good way of doing parameters. I want to do item area. Here I want to multiply it by the depth of our concrete pad. So I think it was 4 inches in deliverable 7. So I'll use 4 inches, but my area is going to be in feet. That's the unit. Or sorry, we specified cubic yards. So I'm going to take this 4 divided by 12, which converts this into feet. And I think it will do it into cubic yards for us. I believe this is in square feet, then it's going to multiply by feet and then convert to yards, but we can find out together. So that's how you can do a volume, for example. Let's say my sidewalk is permeable concrete, so might just do that here. You can see that didn't work super well, assigning it to as a point. So I'm going to do it using object, and I'll select the line myself. The entity must be a polyline, so I'll use the polyline. There we go. Here I'll use the same formula, item area times 4 divided by 12. If we had this in weight, then maybe I would multiply by 150 pounds per cubic foot and then divide by 2,000 to get it into tons. That's something you could do, and then you could have your item be by weight instead of by volume. So these formulas are really powerful. It automates everything and does it in the program for you, which is really nice. Whenever you are done, we can use the takeoff command. So you can see it's right here. It's also up in the bar. So I'll execute the takeoff. You can do a summary or detailed. I will just do summary, drawing sense, and here I'll just click compute. And it opens this up. This makes no sense to me, so let me go down here and put this into an HTML format, and that looks much better now, right? So I can put this in my drawing and place it down. And there's my quantity takeoff report. So I think it might have actually kept it in square feet for us. I don't believe our concrete pad is 933 cubic yards. That sounds like a lot. I guess we can check it really quickly. 933 cubic yards to cubic feet. So I think you multiply by 27. Yeah, that's definitely not right. So I might need to go in here and divide by 27, actually. This is converting cubic feet into cubic yards. Save that. And similar to your like stormwater or your cut fill report, it doesn't update automatically. So I'll just make it again, compute, and then put it in my drawing. That looks much more reasonable at 34 and 20 cubic yards respectively. And that is your quantity takeoff. So this you need to include in your report. So include this table directly. You can include this as a plan sheet or a screenshot as a PDF. Alternatively, if you convert this to an HTML file like it is, I think you can actually save it as an HTML file and then save that and convert it to a PDF. However you choose to do it, this needs to be part of your submission. Then you'll also take this data and put it into your cost estimation. So I think my concrete here was 34.5 yards, for example, cubic yards. And that gets me my line item cost. Just jumping in here really quick to mention the retaining wall. The retaining wall isn't on your proposed site design files, but it is something that we made that isn't already existing. So we're going to include the retaining wall here as well for the concrete. Now in deliverable 7, for the overturning moment problem, you were given a cross-section of the retaining wall with all the dimensions marked out. So you should be able to find the cross-sectional area of the retaining wall. It's pretty much one big rectangle on the bottom with the little key at the very bottom of it. And then I think it's a trapezoid on the top that represents the actual wall structure. And once you have that cross-sectional area, you also know how long your retaining wall is. So you might need to reopen that deliverable 4 or maybe from deliverable 7, one of those files. But if you go into your corridor properties where it lists out all of your different corridors that you have assigned and different assemblies that you have assigned, you know the start station and the end station for the retaining wall. And you guys know how to read stations, so you can find out how long your retaining wall goes for. So now you have the cross-sectional area and you have the length of the retaining wall. So you can find the volume of concrete that you need for that. Just make sure you do it in cubic yards, right? So if you're calculating in inches or in feet, you have to do the dimensional analysis to convert into cubic yards. So do that and add that to this quantity as well. And any other additions you have for concrete or cement, be sure to add those as well. Right. So again, you need at least 5 items for your QTO table. That's this one. There needs to be at least one volume, at least one counting, and at least one that is by area. Let us know if you have any questions. I hope that makes sense. Once you've completed this, you are totally, and I mean fully, done with Civil 3D. The Gantt chart that we're making will be entirely in Excel. So pat yourselves on the back. You guys have learned a lot, done a ton, and I hope you feel more equipped for any interviews, internships, or future classes that you guys have.